Hello and welcome to the HPDC Pathshala. I am Bharat Sharma, the founder of Steady Diecasting Solutions and HPDC Pathshala. Today we are diving deep into the fascinating world of high pressure die casting, or HPDC for short. If you are looking for this content in Hindi, so do check out my YouTube channel HPDC Pathshala Hindi, and remember more for more advanced learning and exclusive resources, visit my website at www.hpdcpathshala.com. So die casting is a complex and dynamic process that involves multiple variables: molten metal and high pressure die casting machine, expensive dies, extremely high pressure, and high temperature, and control, and most importantly, safety considerations. So, unlike other manufacturing operation, a die casting operator is not merely a machine attendant. Instead, they play a critical role in monitoring and adjusting multiple factors to ensure good casting parts are produced consistently. So the challenges here is that the many of these factors tend to drift out of alignment during the production and requiring constant vigilance and adjustment from the operator. So let's start by understanding the basic of high pressure die casting process. In HPDC, molten metal is injected into steel die under high pressure. The high pressure ensures that the molten metal fills every space between the die halves within a milliseconds, or you can say uh, 30 or 40 milliseconds. The, men- the metal solidify as it lose heat to the die, and once the solidification is complete, the die open and the short or solid casting is removed. The beauty of this process lies in its ability to produce a net shape or near net shape component in just one manufacturing step. However, internal porosity remains a significant challenge to tackle this. We have evolved our process from conventional high pressure die casting to more advanced methods like fuse casting with vacuum technology and even semi solid state casting technique. So for now, let's focus on the conventional high pressure die casting, including both the cold chamber and the hot chamber process. So two primary injection mechanisms are used in HPDC: the cold chamber and the hot chamber mechanism. In the cold chamber process, typically used for metal with higher melting points such as aluminum, magnesium, and brass, the molten metal is ladled into a horizontal steel tube called the cold chamber or short sleeve. A short plunger then pushed the metal into the die. The portion of metal that remains in the cold chamber and solidify with the casting is known as the biscuit thickness or biscuit. On the other hand, the hot chamber process is deal for metals like zinc and lead, which melts at a lower temperature. Here, the plunger and cylinder are submerged directly into the molten metal, allowing the cylinder to refill automatically after each cycle. However, this process is not suitable for metals like aluminum and magnesium due to the high temperature reaction that cause rapid deterioration of the gooseneck. The choice of magnesium significantly impact the operator responsibility, which we will discuss next time. So one of the critical aspect of the high pressure die casting process is the clamping mechanism. Due to the high pressure required to inject the molten metal into the die, we need many tons of force to hold the die halves together. This is achieved using a tie bar platen toggle type machine construction. This mechanism not only provide the necessary clamping force but also allow for rapid opening and closing of the die, which is essential for achieving high production rates. Next, let's talk about the metal handling. In the die casting, the molten metal is transferred from a holding furnace into the injection chamber or short sleeve. The metal is usually transported using ladles, often by trucks or overhead rails from the melting area to the holding furnace. In some setups, heated through a launder transfer the molten metal from the melting furnace to the multiple holding furnace, optimizing the process for higher efficiencies. Once the shot is removed from the die, it contains excess material known as trimming, such as sprue runners and overflow cavities. These trimmings are cut away from the usable casting using a trimming press. The trimming are the recycled and melted again and reused, minimizing the material waste and enhancing the process sustainability. Sometimes the die casting operator is responsible for managing the trimming press as well, or they may transport the casting to the another operator for trimming. This decision often depend on the specific type of casting being produced. So, in summary, high pressure die casting is a complex yet highly efficient manufacturing process that offers many advantages, such as producing component in a near net shape with the high precisions. However, it comes with its set of challenges, such as the internal porosity, which is constantly being addressed through innovation in the field. This brings us to the end of today's videos. Remember, continuous learning is the key to mastering any craft. If you are passionate about it and deepening your knowledge in the die casting, so don't forget to visit my website www.hpdcpathshala.com and consider becoming a member for access to the advanced learning resources and HPDC problem solving software. Your support will make HPDC Pathshala a reality where we can build a learning hub for all things related to the die casting, training on HPDC machine, die design, process control, and much more. Together, we can push the boundaries of these industries. Thank you for watching. See you in the next video. And until then, keep learning till death.